Audrey Hepburn. Distinguished resource person, faculty members, and my dear participants, Assalamu alaikum and a very good afternoon to one and all present over here. It gives me immense warmth and great pleasure to grace all of your presence in 1 week workshop on research methodology organized by Department of Economics, Postgraduate and Research Center, YNM AKI, Poona College of Arts, Science and Commerce. The research methodology workshop is organized to facilitate the academic requirements of the postgraduate students, research scholars, and faculty members of various colleges and universities. The 1 week workshop on research methodology is conceptualized with the intention of knowledge building on the fundamentals of research concepts, information of various tools, application with inputs on the essential of academic writing. Today, we have come to the second day of the workshop, and I consider it as a great honor to welcome and introduce our resource person of the day, Dr. Absar Ahmed. Sir is an assistant professor at the Department of Community Medicine, Manipal Tata Medical College, Manipal Academy of Higher Education, Jamshedpur. Sir has done his PhD in population studies. Can you all see my screen, please? Sorry for the interruption. Is my screen visible?
Yes, ma'am.
Yes, ma'am.
Absar's PowerPoint presentation.
It's visible.
Thank you, sir. Sir has done his PhD in population studies from the International Institute for Population Sciences, Mumbai in 2019. Sir has done various short-term courses on operational research in public health, ethics review of health research, and also he has been honored with many awards. Recently, sir has received a grant for low and middle income country in 33rd International Congress on Occupational Health to present a paper digitally at ICOH 2022. Sir has also scored a second rank in National e-poster competition at the second National Conference of Epidemiology Foundation of India, organized by Community Medicine and Family Medicine and School of Public Health, All India Institute of Medical Sciences, Jodhpur. Sir has also received a Young Investigator Award to attend Asian Conference on Occupational Health held in Fukuoka, Japan on 2nd to 4th September. Sir has many publications in national and international repute. He is having teaching experience of various subjects, and his area of specialization is biostatistics, demography, and epidemiology. Sir has an research experience of more than 12 years, and currently, like I said, he is the member of many professional associations also, like Indian Association of Social Sciences and Health, Indian Association of Medical Statistics, and he's also the life member of Association of Environmental and Occupational Health, Delhi. So with this brief, very short introduction of Absar sir, I would welcome you for the second day of workshop on research methodology.
Thank you, Dr. Anna, for your kind introduction. And I am sharing my presentation. Is it visible?
Yes, sir, it is.
Hello, good. And today I am going to present a topic entitled Quantitative Research Methods. The process of undertaking research. What is the process? Basic steps. We firstly start with by choosing a topic of your interest in which your interest of your topic. Then you go for literature for that related to your interested topic, research interest topic. And for literature review, you go to search through journal article, books, and monographs, and also newspaper article for your literature search. On the basis of literature search, then you identify the research problem, where is the research gap available, and what is already happened on that research topic and what has not happened on that research topic. Then you develop a research question, and after developing your research question, you choose for your research design, how you are going to solve or answer your research question. And when you decide, when you select your research design, then you go for collect the data using some using qualitative technique or quantitative technique. And when you have collected your data, then you go for analyze. And for qualitative data, there is a separate analysis, and for quantitative data, there is a separate analysis. And then after analyzing data, then you interpret the data. You write a discussion or result and discussion of your research, your topic. And then after that, you will send that a report or thesis, you submit to it, or you can go for publication, research publication. But you have to careful about publishing your research paper, and careful for research paper, because there is so many pirated publication journal is available right now. So you have to be careful for publishing your research topic in which you have lots of time invested on that. So be careful before publishing it. What now my next topic is research design. What is research design? Research design is a framework of research methods and techniques chosen by researcher. It's totally depend on the researcher time and money they have available for that research work. If it's a funded research, then you can go for large sample size and good sampling design. But if you do not have much fund available for that research, or you do not have much time, then you can go for different research design which suit to your time and money. Or research design is a structure and strategy of investigation to answer your research questions. How you are going to answer your research question is the research design. The design phase of a study determines which tools to use and how they are used. And this comes under research design. And impactful research usually creates a minimum bias in data. If our research design has minimum bias, then it is considered as a good research design. And if it has more bias, I will discuss later how biases come in a study design or research design. Our good research design also have a least margin of error. The margin of error tells how many percentage points your result will differ from the real population value. Characteristic of a research design. Objectivity. Objectivity of a research finding are thus the one that any other researcher performing the observation or the same researcher using different method would also arrive at the same interpretation. And the findings are said to be objectivity when they pertain to the method of data collection and the scoring of the responses. The objectivity is also ensured by comparing notes or having other people look at your data and your method and your conclusion. If they make the same inferences, whatever you have done, whatever your finding comes in, comes and other researchers are also reach to the same conclusion of your research, then it is called objectivity. Another characteristic is reliability. With regularly conducted research, one expects similar result every time. Then it is called a good research design. Design is reliable. If your research every time, if you conduct a research, then you will find similar result every time. Then it is called a reliable research design. Your design should indicate how to form research questions to ensure the standards of result. You will only be able to reach the expected result if your design is reliable. Validity. There are multiple measuring tools available to measure the validity. However, the only correct measuring tools are those which help a researcher in gauging results according to the objective of the research. The questionnaire developed from a design will then be called as a valid. Generalization. The outcome of your design should apply to a population and not just to restricted sample. If you have done any study, if you cannot replicate in other area, then it is not a good research design. A generalized design implies that your survey can be conducted on any part of population with similar accuracy. Now we have generally two types of research design. One is called qualitative research design, another is called quantitative research design. Qualitative research design can give solutions such as how and why some events is occurring, and which qualitative research mostly used to discover ideas, explain number of and formulate prediction. In qualitative research design, generally we have a qualitative outcome variable which cannot be quantified, and we do not have much information about that research question. Then generally we use qualitative research design. Generally, if we have some new topic which we do not have much information, we want to explore that topic, then we generally use qualitative research design. And in quantitative research design, aims to answer queries such as who, what, where, how many, and when. And generally, we answer the question through numerical terms or through quantitative variables. Types of first research design is exploratory or formulative design. Exploratory research is a methodology approach that questions that have not previously been studied in depth, and it is generally a qualitative in nature. The main purpose of exploratory study is to gather information which help in a future for formulation of precise research problem. On the basis of the collected facts, the researcher may be able to formulate sound hypotheses for further research. Through exploratory research design, we can formulate the hypothesis which previously not any researcher have done. So you can give a hypothesis, you can generate a hypothesis through exploratory research design. In descriptive research design, the purpose of descriptive type of design is to describe some event, situation, people, group, or community. only described about the population. We can discuss. Suppose the example of descriptive research design is a which gender is mostly what is the which gender is mostly died through COVID-19, which age of the which age category of the people died COVID-19. If we are going to study some epidemiological study, that is called as descriptive research. We describe that the this male or female is mostly died through the COVID-19, or age category more than 60 is mostly died through the COVID-19 or any disease. That is called descriptive research design. We only describe about the population. Experimental design. Third one is experimental design. Experimental research is a study that strictly adheres to, it's a mostly scientific research design. It includes a hypothesis, a variable that can be manipulated by the researcher, and variables that can be measured, calculated, and compared. In experimental, the example of experimental design is a RCT, randomized controlled trial, in which we have, which we can control the outcome variable in research. Or mostly that in medical research, this is conducted, or in physical science. Systematic study of systematic study of human relation by making the observation under condition of control. In city, we have a two group. One is called experimental group, another is called control group, and we give some intervention to the experimental group, and we measure the outcome of intervention in both the group, in experimental group as well as in control group, and we measure the outcome after that. Suppose if we are in drug trial. In drug trial, mostly RCT is done. We give some particular drug to experimental group, and in control group, we give placebo. Another research design is correlational design. Correlational research design enables the relation between two related variables. This type of research design method needs at least two data groups, and both are in quantitative in nature. In diagnostic research design, researcher wants to know about the root cause of the problem. He describes the factor responsible for situation. In this research design, researcher strive to for the occurrence of certain circumstances. The method can assist you in examining in depth the element that cause a specific challenge that your customer may face. Another research design is explanatory research design. The name suggests explanatory design is utilized by researchers to explore, expand, and explain theories and innovative ideas. The design method is applied to find the missing pieces of puzzle or obtain clarity on a vague aspect of certain topic. It is explanatory research design is based on a researcher personal judgment and obtaining information about something he is looking for an unexplored situation and bring it to the eyes of the people. In this type of research, there is no need of hypothesis formulation. Now there is some research design which is based on grouping. First one is cohort design. In cohort design, generally we follow, it's a prospective type of study, and we follow a certain group having a similar characteristic. Suppose we want to do a study. Suppose we have one group of a smoker. Suppose a smoker. Or suppose a tea drinker. Suppose we have a group of tea drinker who is taking tea daily. and another we have a group which is not tea drinker, and we follow that group, and we will see which group will have a diabetes in future. We follow a sugar level of that two groups, and we can see the diabetes who will suffer from diabetes in future, and how many people of tea drinker is suffer from diabetes. People who is not as tea drinker will suffer from diabetes. It's a hypothetical example. Research design. Another is cross-sectional design. In cross-sectional design, we collect the data at a one instance, and if we go in a community and collect data in only one time. We are not going more than once time for a collection of data with the same people. This is called a cross-sectional design. So mostly most of the study, and whatever study I have done till is mostly a cross-sectional research design. Another research design is longitudinal research design. A longitudinal research design in which we generally collect the data from one people more than once. And today we have collected the data from a group. We are going to collect data after 6 months or 1 year from the same people, like that. This is a longitudinal research design. Another is cross-sectional, cross-sequential design. It's a mixture of longitudinal and cross-sectional research design. Cross-sectional design study combines both the cross-sectional and longitudinal analysis, working to make up for some inherent issues in both research methodologies. Another and the last one is case control study. A case control study is a way of carrying out a medical investigation to confirm or indicate what is likely to have caused a condition. Suppose we have already have a diabetes and another group which do not have diabetes, and we follow it retrospectively. We go in back time and we try to investigate that what factor that cause the diabetes to that people. So it's case control is a retrospective study and study, and this type of study design mostly used in a health research. Now, a sample is a smaller collection of units from a population used to determine truths about the population. Why we need sample? Let's have one example. The Literary Digest poll in 1936 used a sample of 10 million drawn from a government list of automobile and predicted Alf London would beat Franklin Roosevelt by a wide margin, but instead Roosevelt won by a landslide. Why this sampling has gone wrong? Because the Literary Digest who conducted the study has taken the list of automobiles and telephone owners, and this automobile and telephone owners do not represent the whole population, because only few people who have an automobile at that time, and only few people or rich people an automobile in 1936. So they have conducted a study only on rich people. That's why this sampling gone wrong. This study gone wrong. Why do we? Because cost in term, because if we go with census which is census is a sample consisting of entire population, which we are going to enumerate all the population. It's called census. As so doing census always is not possible. That's why we need, and conducting a census is a costly affair. We need time and manpower. That's why we need a sample survey. And conducting a census is also very cumbersome, and therefore cumbersome. Therefore, sometimes there is a chance of error also if we are doing census. Sampling is a process of selecting a representative sample from a population. If this rounds in sampling and with the sample, we have a population a large. We take a small part from that that population, which is called as sample, and collecting the sample from a population is called sampling process. With the sample, we in population we estimate we test the hypothesis on the basis of sample about the population. The process of obtaining information from a subset of a larger group is called a sample. Sample are then used to make estimate of the larger group already discussed. It's faster and cheaper than asking the entire population, which is usually done in the census. And the selecting the right people in sampling, what is the important? We have to select the right people. We have to select scientifically, so they are representative the whole population, and we also keep in mind taking care of to minimize the sampling error. If we go the wrong people, then there is a chance of sampling error. It's in population. If we have any estimates from a population, that is called as parameter. If we have any estimates from sample, that is called a statistics. Through sample, we estimate about population. Through statistics, we estimate about parameter. Characteristics of a good sample representation. Sample survey are almost never conducted for the purpose of describing the particular sample under study. Rather, they are of understanding the larger population from which the sample was initially selected. A great deal of work has been done over method that provides representative sample for the general population. We have a famous international survey. One is called as Demographic Health Survey, which is conducting in, I think, more than 80 countries, including India. In India, it is called as National Family Health Survey. Famous sampling survey is expanded program on immunization. Conducting in many countries. This is a famous sample survey study. 3 factors that influence sample representativeness. One is sampling procedure, another is sample size, and third one is participation response. If we do not have good sample, if we do not choose a good sampling strategy to select a sample, then it will affect the representativeness of the population. If we have not sufficient sample size, then it will affect the representativeness. And if we have more non-response of the participation, then it will also affect the population. When might you sample the entire population? When your population is very small, when we have our population size is small, we will go to study the whole population. When we have when we have a large we have a funded project, then we go for a large sample. We have a small population, Then we go to for entire population. A population, or also called as target population, is a group of individual person, objects, or items from which the samples are taken for measurement. It also refers to entire group of individuals or sub-objects to which researchers are interested in generalization the finding. Basic terms also. Who do in when who do you want to generalize to? So then we have a theoretical population which we generally generalize in our sampling procedure. In sampling, what population can you get access to? The study population. How can you get to access to them? To sampling frame. And who is in your study? The sample. This is the basic concept in sampling. Census we already discussed. What is sampling frame? Is the list of people from which the sample is taken. It is the list from which the potential respondents are drawn. It should be comprehensive, complete, and up to date. Frame can be electoral, all the electoral register people, and some telephone number and postcode address file, etc. Probability sampling. What is probability sampling? With probability sampling method, each population element has known chance of being chosen for the sample. In probability sampling, we choose a sample in a random way, and each participant, each respondent have equal chance of selection in that sample. What is non-probability sampling? With non-probability sampling methods, we do not know the probability that each population element will be chosen, and or we cannot be sure that each population element has a non-zero chance of being chosen. In non-probability sampling, we do not know the probability of chance of the participants, but in probability sampling, we know the probability of chance of selection of the participant. What is sampling unit? The unit of selection in the sampling process. A study unit. What is study unit? The unit on which information is collected or on which the observation are made. Example, families, towns, branches of a company, individual, subject or school, etc. The sampling unit is not necessarily the same as the study unit. If the objective is to determine the availability of latrine, suppose toilet, then the study unit would be the household, not a toilet. If the objective is to determine the prevalence of trachoma, it's some type of disease, then the study unit would be the individual. What is the sample fraction or sampling interval? The ratio of number of units in the sample to the number of units in the reference population. It is calculated by total sample size and total population divided by sample size. This is the hierarchy of sampling. From below we start. The population to whom result would be applied, that is called as target population. The population from whom the study object would be obtained, that is called as source population. The list of potential subjects from which the sample is drawn is called the subject who are selected is called sample, and the actual participant in the study is called study subjects or sampling units. Errors in a statistical study. A sample is expected to mirror of the population from which it comes. However, there is no guarantee that any sample will be precisely representative of the population. If we are doing any sampling, there must be some error. We try and our aim is to minimize that error. No sample is the exact mirror. Error, one is called sampling error or random error, another is called non-sampling error or systematic error. Random sampling error or random error is not representative of the population due to chance. If we select a population sample which is not representative of the population, it's called a random error. The uncertainty associated with an estimate that is based on data gathered for a sample of the population rather than the full population is known as sampling error. A sampling error or the random variation in the sample estimate around the true population parameter. If there is a deviation, if we estimate through a sampling, if we estimate a parameter through a sample, then there is some deviation from the true values, that is a sampling error. The level of it is controlled by a sample size. If we increase the sample size, then our sampling error will decrease, and it happens to be of a smaller magnitude in case of homogeneous population, in which sampling error is 0. Why do sample estimate have uncertainty associated with them? There are two reasons. Estimate of characteristic from the sample data can differ from those that would be obtained if the entire population were surveyed. And estimate from one subset or sample of the population can differ from those based on different sample from the same population. There is sample to sample variation. What causes the sampling error chance? Main cause of sampling error and is the error that occurs just because of bad math. If we select a wrong respondent or wrong people in a study in our sample, then it causes sampling error. And there is also a sampling bias. If we select non-probability sampling, then there is a chance of sampling bias. Sampling bias is a tendency to favor the selection of participants that have a particular characteristics. If a researcher tendency to bias of selection, then it causes sampling bias. The chance component, sometimes called also random error, exists no matter how carefully the selection procedure are implemented, and the only way to minimize chance of sampling error is to select the sufficient large sample. So only way to reduce the sampling error, we have to increase the sample size. What is non-sampling error? It is a type of systematic error, the design or conducted of sampling procedure which result in distortion of the sample so that it is no longer representative of the reference population. We can eliminate or reduce the non-sampling error or bias by careful design of the sampling procedure and not by increasing the sample size. It can occur whether the total study population or sample is being used. The basic type of non-sampling error is non-response error or response or data error. A non-response error occurs when units selected as a part of sampling procedure do not respond in a whole or in a part. If we are going for any study and respondent do not answer the whole questionnaire, then it occurs a non-response error. Then it causes a non-response error. And when the non-respondent constitute a significant proportion of the sample, and if we are going for a study and there is a more non-response from the participant, then it also causes non-response error. Response or data error is a systematic bias that occurred during data collection, analysis, or if a research investigator go for a study and he fill a wrong information, that error is caused by respondent interview, that caused by a who is conducting the interview. That error is conducted by interviewer. And if respondent has given the wrong information, that is called a respondent error. And during the data entry, if the data entry operator has entered the wrong information, that is called as recording error. And if we develop a poor design questionnaire, this is also called cause a non-sampling error. So we, in our study, if we are conducting any study, we try to minimize or these not minimize, we do not occur this non-response error, because we cannot justify sampling error. We cannot make it nil, but we can try to avoid this non-response error, which is in the hand of researcher. But the sampling error is not in the hand of researcher, but non-sampling error is in the hand of researcher, and we try to minimize as possible as. Systematic error makes survey result unrepresentative of the target population by distorting the survey estimate in one direction, which is non-response error. Random error can distort the result in any given direction but tend to balance out on average. Thus, the total survey error is sampling error plus non-sampling error. So we can minimize sampling error, which is not in the hand of researcher, but we have to make non-sampling error as a zero. Advantage of sampling. We obtain a sample rather than a complete enumeration of the population for many reasons. One is called feasibility. It may be only feasible method of collecting the data because census is not feasible every time. It is conducted in only in 10 years. And reduce cost. Sampling through sampling, it reduces cost. Sampling reduces demand on resources such as finance, personnel, and material. Greater accuracy, it gives greater accuracy. If we have selected a good research design, then it has a good accuracy. A greater speed, we can get a result in a very good time. This disadvantage of sampling: if sampling is biased or not representative or too small, the conclusion may not be valid and reliable. If the population is very large and there are many sections and subsections in the population, the sampling procedure becomes very complicated. Because if we have many sections and subsections in our community, so then representativeness of that section and subsection is very complicated to make a representativeness of that section and subsections. And if the researcher does not possess the necessary skills and technical knowledge in the sampling procedure, then the outcome will be devastated. Characteristic of a good sample design. From what has been stated above, we can list down the characteristic of a good sample design. As sample design must result in truly representative sample. Sample design must be such as result in a small sampling error. Sampling design must be viable in the context of funds available for the research study. Sample design must be such so that the systematic bias or non-random error can be controlled in a better way. Sample should be such that the result of the sample study can be applied in general for the universe with a reasonable level of confidence. Types of sampling. How we select the right subject. The sample that we draw for our study determines the generalizability of our findings. Samples should have a good representation of this population. While conducting a sampling, we have in mind that our sample should be a representative of the population, and whatever we find in our result that can be generalized to the whole population. There is a two type of sampling method. One is called probability sampling method. Another is called non-probability sampling method. In probability sampling method, we have simple random sampling, systematic sampling, stratified random sampling, and cluster sampling. And in non-probability sampling, we have convenience sampling, quota sampling, judgment sampling, or purposive sampling, or snowball sampling. Probability sampling method is a random, random means equal chance of selection of each participant, and independent component of random sampling. There is no biasness from the researcher side. Component of random sampling are what make us confident that the sample has a reasonable chance of representing the population. If we do select a population sample through random and an independent way, then it's truly represent the population. What does it means, the independent? Dependent means the researcher select each person for study separately. Let us say you were asked to participate in an experiment, enjoyed it, and told your friend to contact the researcher to volunteer for the study. This would be example of non-independent sampling. In probability sampling, a sampling frame exists or can be compiled. Before doing a probability sampling, we need a sampling frame in which all the list available of our study target population and should have an equal or at least known or non-zero chance of being included in the sample. If we have a sampling frame of a target population, then we can calculate the probability of selecting of each participant. And generalization is possible through a random sampling. And in these are the type of sampling. No, simple random probability sampling. First one is simple random sampling. Simple random sampling is the most straightforward of the random sampling strategies. To use simple random sampling, there should be a sampling frame for the population. We must have a sampling frame of the population. All possible sample of n subject are equally likely. So then the sampling, then the probability of selection of each participant is 1/n, and population is when the simple random sampling is used when we have a small population. When we have a large population, we cannot make a sampling frame. We do mostly there is a chance we do not have a sampling frame for a larger population, but for a smaller population, we can make a sampling frame. And then when we have a relatively homogeneous population, then we use simple random sampling. And when we have sampling frame, which is available, then we use simple random sampling. Procedure to select the sample. The specific procedure that you follow may vary depending on your resources, but all involve some type of random process. Depending on the complexity of the population, we can use different tools to select the sample from the given sampling frame. The mostly common is a lottery method. If we want to do select a sample through a simple random sampling, then we make a chip or lottery of all the participants in a sampling frame, and then we select whatever the sample size, we can select that number of lottery from that boxes where all the cheat is available. Another method of selecting the people participant or respondent is a random number table, which is available in internet or any textbook. It is look like this way, and we can use it in any direction. If we can go through or we can go horizontal as well as vertical for selecting a sample. So for example, suppose we have 100 students in a class, and we want to select 5 people, and these 100 students are having a roll number 1 to 100. We want to select 5 students. Then we go with 2-digit number for selecting a 5 student from that 100 class. Suppose if first number is 36, then 36 roll number we can select. Another student is 51, second student is 51, third student is 83 roll number, fourth student is 67 roll number, or fifth student is 77 number. If we can go vertical as well, we can select a 36 roll number student, then second student is 46 roll number, third student 31, fourth student is 84, and fifth student is 78. We can start from any part of this random table. We can start from first row, second row, third row, anywhere you can start to select your sample for your sample for your study. This random number table is available everywhere. You can search Google or text. Lottery method is appropriate if the total population is not too large. Otherwise, if the population is too large, then it will be very difficult to use lottery method. If we have a large population size, we do not use a lottery method. We do not use simple random sampling. Sampling if we have a large population, because we do not have a sampling frame for a large population. If it is available, then we can use. But if it is not available, then we make a sampling frame or large population is very difficult. And another is a random number table, which from which we can use a sample. For example, assume that the total number of a patient who visit a hospital for the last 6 months is n. Suppose from last 6 months, in any hospital in a city, the number of patients, and we want to see the prevalence of TB among those patients who visited the hospital. That is called as a small n. So we can do as we can select if we have a list of that patient visit. Suppose there is a 5,000 patients have visited in last 6 months in a hospital, and we have a in that 5,000 there may be some TB patient also visited for a TB patient also among the patient in that 5,000. Then we can select that TB patient through a simple random sampling. If we have a suppose we have a from 5,000 there is 100 TB patient visited among the patient. We want to select 5 patients. Do a random sampling using lottery method. We can make a list of all the 100 TB patients, and we can select the 5 patients through random simple random through lottery method or random number table. Another sampling method is systematic random sampling. Systematic sampling is thought as a random as long as periodic interval is determined beforehand and the starting point is random. A method of selecting sample member from a larger population according to a random starting point and a fixed periodic interval. Typically, every nth member is selected from the total population for inclusion in the sampling population. It is frequently chosen by researchers for its simplicity and its periodic quality. It needs the population to be homogeneous, however, the method does not require the frame. Steps in systematic sampling. When we have a target population, suppose we need the total population size. Suppose we have a total population size is n. Suppose it's a n, and we desired sample size is a small n. Then we determine the k, that is calculated by capital N divided by n, and we select a random number between 1 and k. Suppose we have suppose capital N is 100 and a small n is 5. So capital N 100 divided by small n, that is a 20. So k is 20. So we select a random number between 1 and 20 through a lottery. We can select. We can go with lottery method or random number table, or in Excel there is also a command random number between 1 and 20. If we write rand between 1 and 20, it will generate a random number between 20. Suppose it's 15. let denote the number by A. Suppose A is 15. So starting at A, take every kth number. So first sample is 15 number. The the second sample will be A plus K, and 15 plus 20. Third number is A plus 2K, means 15 plus 20, 35, 35 plus 15, 15, 35 plus 20, it's come around 55, then 55 plus 20, it's a 75. Like that, we will select the sample in a systematic sampling. Systematic sampling should not used when a cyclic repetition is inherent in the sampling frame. If we have if in a sampling frame already there is some type of repetition, if there is possibility that we catch that repetition, and then it will come as a bias, and our finding will be biased, or result will be biased. Here is the example. If suppose small capital N, yeah, population size is 1200 and sample size is 60, then sampling fraction or the small k is 1200 divided by 60, it's 20. Then we select. Then we will select a random number between 1 and 20. Suppose it's come as a 8, and first person will be 8 on the list. Second person will be 8 plus 20, 28. Third person will be 28 plus 20, like that. Systematic, it relies on arranging the target population according to some ordering scheme, and then selecting the element at regular interval throughout the order list. Systematic sampling involves a random number start and then proceeds with the selection of every kth elements from then onwards. In this case, K is the population size divided by sample size. It is important that the starting point is not automatically the first in the list, but is instead randomly chosen from within the first to the kth element in the list. But sampling is a random sampling. If we do a random sampling, there is a chance that if suppose, for example, suppose we have a 100 student in a class. That student is a mix of some are male and some are female. If we choose five students from that 100 students, so there may be chance that all the 5 students which I am going to select may be male or female. There might be chance that all are male or all are female. So then our sample is not the representative of the class. Then what we will do? We will use a stratified random sampling, in which we make a strata or group of group for male, separate for male and separate for female, and we select proportionally or equal, can select equal, or as we can select as a proportion of the population through both the group. If we go in if we are going in a community, then our sample will be representative of the community if we have all the religious group included in our sample and all the caste group is included in the sample. So we have to take care. Then stratified random sampling is take care of that group. In a stratified random sampling is used when we have a subgroup in our population that are likely to differ substantially in their responses or behavior if the population is heterogeneous. In a stratified random sampling, the population is first divided into a number of parts, strata or a group, according to some characteristic like gender or religious group or caste group chosen to be related to the major variable being studied. If our aim is to study the gender-wise or religion-wise, then we have to take care. We have representativeness of these groups. For example, you are interested in visual spatial reasoning. It's some type of intelligence test in psychology, and previous research suggests that men and women will perform differently on this type of task. So we have a sufficient number, sufficient size of male and female in the sample. We have to take care through stratified random sampling. You divide your sample in that type of cases, we divide the sample into male and female member and randomly select the required sample size within each group, also called as a stratum, each subgroup. With this technique, you guaranteed to have enough of each subgroup for a meaningful analysis. Often we use simple random sampling to select the sample from each strata after stratification. When we have a when we make a lottery of male in a one box and female in a one box, then we select the male sample and female sample from that group using a simple random sample. Involves in stratified sampling method. We define the population. First, we have to define the population, our target population, determine the desired sample size. What is our sample size? Identify the variable and subgroups for which you want to guarantee appropriate representation. It can be proportional or might be equal. Classify all members of the population as a member of one of the identified subgroups. Randomly select and using random selection, an appropriate number of individuals from each group to select randomly. Then the total sample size will be sum of all the sample from each subgroup. There are two methods to get the study subject from each subgroup. One is called proportional allocation, another is equal allocation. Proportional allocation means if we want to study on a community, so we want to representative of the population religious. Suppose we want to the representative of all religious group of our country. So if we go for proportional allocation, then we have a sample in which whatever the proportion of our religious group in our population, that will same in our sample as well. So suppose 80% is the Hindu in our country, then we in our sample 80% of Hindu in our sample also. If 14% are in our country, there is a 14% Muslim, then in our sample there must be a 14% Muslim. Then this is called a proportional allocation. According to proportion, we are in proportion of a population, that proportion same in our sample as well. This is written in this slide. The higher the population in the subgroup, the higher the sample size will be. However, equal allocation will be used if the total population for each subgroup is approximately equal. If subgroup is equal, if the proportion, suppose in a class male and female is equal, then our sample also the male and female will be equal. Advantage of stratified sampling over simple random sampling. Representativeness of the sample is improved in a stratified random sampling, but in simple random sampling it is not guaranteed. That is adequate representation of the minority group subgroups of interest can be ensured by stratification and by varying the sample fraction between strata as required. The merit sampling frame for the entire population has to be prepared separately for each stratum, which is cumbersome, which is difficult. Cluster random sampling. In this sampling scheme, selection of the required sample is done on the groups of study units, which is called as cluster. instead of each study unit individually. Cluster in this study in sampling, cluster is is having some boundaries or some fixed boundaries, like a village. In a village in India, the village has a fixed boundaries, like then it is considered as a cluster. So, another cluster example of cluster is suppose a school. School has a fixed boundary. There is a student, there is a teaching staff, non-teaching staff, then we consider school also as a cluster. Hospital is also a cluster. A household is also a cluster, the smallest unit of cluster. In a household, there is a children, there is a parents. This is also considered as a cluster. So the sampling unit in this sampling unit is a cluster, and the sampling frame is the list of this cluster. So if we are going to study in a school in a particular city, then we have to make a list of all the schools of that city. If we are going to study in a hospital, suppose in a hospital, then we have to make a list of all the hospitals of that city, or city or state or state. If the study covers wide geographical area, using the other method will be too costly. If we are going to if we are suppose we want to study on a school, we select one school, some respondent from one school in this city, then another respondent from another city, third city, fourth city, another district, second district, third district, like that. So it cover a wide geographical area, then it is very difficult. So if then we can go for a cluster random sampling. We select a one cluster and we go to study the entire unit in that cluster. If we have a time or money, then we can select more than one cluster, 2, 3 cluster we can select. The idea is divided the total population into a different cluster, and then the unit of selection will be a cluster. Therefore, total population in the selected cluster will be taken as the sample. Steps in cluster sampling. And first we have to define the population, then determine the desired sample size, identify and define a logical cluster. We have defined our cluster. Can be school, or it can be village, or it can be household. Make a list of cluster in the population. Estimate the average number of population number per cluster. Determine the number of cluster needed by dividing the sample size by estimated size of the cluster. Randomly select the required number of cluster using simple random sampling through lottery method or random number table. Population cluster. In left hand side we have a population, which is a population divided into different cluster, which must be a logical cluster, which have a fixed boundaries. It's left side. In left side we have a population which is divided into cluster, and in cluster sampling we select a 3 cluster using a random number table or lottery method. Fifth one is multi-stage random sampling. It's really a mixture of all the 4 random sampling, or mixture of all the 4 random sampling. In this sampling, we use if we have stages of selection, then for each stage we can use a different sampling method. For example, the administrator might begin with a cluster sample of all the school in a district. Then he might set up a stratified sampling process within the cluster. Within his school, the administrator could conduct a simple random sample of the classes of grades, and also instead of a simple random sampling, researcher can also use a systematic random sampling or any random sampling. By combining various methods, researchers achieve a rich variety of results useful in different contexts. So in the most of the large survey like National Family Survey, they generally use multi-stage random sampling. In first stage, they select a district and first select a district through some random through any random sampling, and within the district they select a village through different random sampling, and in rural area, in urban area, they select a ward in urban area through a different random sampling, and within a within a village, they select a household using a different random sampling. So, like in each stages, they have researcher can use different random sampling method. Non-probability sampling method. In the presence of constraint to use probability sampling strategies, the alternative sampling method is non-probability sampling method. Non-probability strategies are used when it is practically impossible to use probability sampling strategies. When we are going to do a study, then we mostly try to use random sampling. If random sampling is not possible, then we can go with a non-probability sampling method. Non-probability sampling is a sampling procedure which does not afford any basis for estimating the probability that each item in the population has of being included in the sample. Subjective units of population have a zero unknown with unknown probability of selection. We do not know about the sampling frame. Sampling error can not be computed. Survey result cannot be projected to the population. If we are doing a non-random sampling or non-probability sampling, we cannot project to the population. It is not a representative of the population. What is the advantage? But there is advantage: cheaper and faster than probability sampling, reasonably representative if collected in a thorough manner. We can try to minimize our sampling bias. Then there is a possibility that we can get a reasonable representative. First type of non-random sampling is judgmental sampling or purposive sampling. A researcher selects the sample based on their judgment. Researcher exerts some effort in selecting the sample that seems to be most appropriate for the study. This depends totally on the researcher judgment, and and they can select the participant according to their judgment. This is used primarily when there is a limited number of people that have expertise in the area being researched. Second one is convenience sampling. Convenience sampling involves the sample being drawn from the data from a conveniently available pool of respondents. The sample would generalize only the similar program in similar cities. The major difference in that the cluster of research participants are selected by convenience rather than a random process. Sometimes known as a convenience sampling, sometimes known as a grab opportunity sampling or accidental or haphazard sampling also. A type of non-probability sampling which involves the sample being drawn from the part of the population which is close to hand, that is readily available and convenient. The researcher using a sample cannot scientifically make a generalization about the total population from which the sample, because it would not be representative enough. This type of sampling is most useful for pilot testing. If we are going to check your study tool or questionnaire, then people generally use convenience sampling for testing the questionnaire. Third one is quota sampling. Quota sampling is just like our stratified random sampling, but there is no randomness in selection of the participant. We fix a quota initially that we need a 15 response of 50 male and 50 female, and when that 50-50 is completed, then the study is over. It is a method that ensures a certain number of sampling from different categories with specific characteristics are represented. The specific characteristic in my example is male and female. The investigator interviews as many people in each category of the study unit as he can find until he has filled his quota. If his quota is 50-50, then when 50-50 is over, then his study is completed. It is a non-polarity equivalent to stratified sampling. This differs from stratified sampling, where the stratum are filled by a random sampling. The population first segmented into mutually exclusive subgroup, and a mutually exclusive male and female are mutually exclusive group. If we are going to study in a community, if we want to do a study in all the religious group, then we fix a quota for each community. Suppose we will take 80 from 80 interview from Hindu, 14 from a Muslim, and 3 study. Yeah, if we have 1,000 sample size, then we have 80% from. We will select we will conduct a study from 80% from Hindu. We will conduct 14% from Muslim, and 3% from Christian, and 1% from Sikh. Like that, we fix a quota beforehand. Right, and that quota must be a mutually exclusive subgroup, like a stratified random sampling. Then judgment used to select subject or unit from each segment based on a specified proportion. For example, an interviewer may be told the sample 200 female and 300 males between age of 45 and 60. Then those are interviewer. If they go to the market or road, they whatever the female 200 whatever the female who is coming from the market or shopping mall, they collect the information. When 200 female is over and 300 male is over, then their study is over. In this it is this second step which makes the technique one of the non-polarity sampling. In quota sampling, the selection of the sample is non-random. For example, interviewer might be tempted to interview those who look most helpful. The problem is that this sample may be biased because not everyone gets chance of selection. This random element is its greatest weakness, and quota versus polarity has been matter of controversy for many years. Snowball sampling. It's a fourth non-polarity sampling. It is a special non-polarity sampling method used when desired sample characteristic is a rare. When we want to do a study on a rare events, then we generally use a snowball sampling. For example, suppose we want to study on a homosexuality, which is a rare events, and people do not want to disclose it openly. So, what researcher will do? They try to locate at least one people who has a behavior of homosexuality. They contact that person, and whatever he has, whatever the information he want to collect from that person, they collect it, and they ask that person, do you know any another person who have such behavior? So then that person must know about that behavior people, and he will direct or help them to locate the second people of such behavior. It's like a referral thing. People refer to second people refer to third to fourth, like that. This type of sampling is called snowball sampling. It's mostly used in a qualitative study design. It's what we need to do in case of snowball sampling is that first identify someone who meets the criteria, whatever the criteria of researcher, and then let him or bring to other he or she. While these techniques can dramatically lower such search cost, it comes at the expense of introducing bias because the technique itself reduces the likelihood that sample will represent a good cross section from the population. Selection of additional respondents based on referral from initial respondent, friends of a friend, used to sample from low incidence or rare population. Sample size determination. Determining the sample size for a study is a crucial component of a study to include sufficient number of a subject so that statistically significant result can be detected. How large a sample do I need? It's for generally in medical research we mostly go for sample size because it's totally depend on the time and cost available for with the researcher. But in social science, if we are doing a study on a community based, then we look for a sample size. And the answer will depend on the aims, nature, or scope of the study and on the expected result, all of which should be carefully considered at the planning stage. If sample size is large, then it is good. It will increase the accuracy, but it is a costly and complex. And if our sample size is small, then it will decrease accuracy, but it is a less costly. So what we will do, we will try to search for a optimum sample size which can be afford, which can be feasible. There are three possibility categories of outcome variable. The sample sizes totally depend on our dependent variable or outcome variables. The first is where the variable of interest or our dependent variable or outcome variable have two alternative responses, yes or no. It is in our outcome variable is in dichotomous or binomial outcome, and then there is a separate method of calculation of sample size if we have a outcome variable in continuous form. For continuous form, the data generally expresses as percentage or rates. Then we have a sample different way of calculation of sample size. When we have a category, then there is a separate formula for sample size calculation. If we have a continuous variable, then we have a separate formula for sample size calculation. This depends on our outcome variable. If we have a continuous variable, then our summary statistics is mean and standard deviation. We can calculate the mean and standard deviation for a continuous variable. So and then in sample size calculation, we use mean and standard deviation. There are several approaches to determine the sample size depending on the type of responsive variable. Whether it is categorical or continuous, we will have two sets of formulas. The sample size determination formula comes from the formula for the maximum error of the estimate and is derived by solving for n. To estimate the sample size for a single survey using a simple or systematic random sampling, need to know estimate of the prevalence of the outcome. Suppose if we want to do a study on a suppose anxiety among the adult population, elderly population. So then we need estimate of the prevalence. If anyone have done a study in the past that have generated that have a prevalence of anxiety among elderly people, then we can borrow that prevalence, estimate of the prevalence, and we can use that prevalence in our calculation of sample size. Then we have to decide the precision. Mostly we use a 5% precision for a precision or allowable. We can also call it as a allowable error. how much error you can allow in your study. So generally, people fix as a 5%. Another another term is design effect. Design effect generally is a calculate. We use design effect in a calculation sample size when we do not use a simple random sampling. If we use a simple random sampling for a selection of a sampling unit, then we do not use a design effect. But when we do not use that sampling method, because simple random sampling considered as an ideal simple sampling method. If we do not use that simple random sampling, then we use a design effect, and design effect we can use as a 1.5 and 2 mostly is 1.5 and 2 is mostly used in a sample size calculation. It means that whatever sample size you have got, you have to multiply with 1.5. If we use a design effect of 1.5, if we use a design effect of 2, then whatever the sample size you have got, you have to multiply with a 2. So it's mostly it make it double. And if we multiply it to 1.5, then it make a 1.5. Then size of a total population and level of confidence, which is generally used as a 95%. If we have a continuous outcome variable, then this condition in which research question is about mean, then we need a mean of a continuous our research outcome variable, interest of outcome variable or dependent variable. Then we need a standard deviation of the population. It is rare that researcher knows the exact standard deviation of the population. Then we can borrow it from the past study. Typically, the standard deviation of the population is estimated from the result of previous survey. If there is no study conducted in the past, then we have to go for a pilot study, or we can try to find it from any secondary data, or in last option is judgment of the researcher. But we have to write everything in your data and method parts, how you are calculating your sample size and what value you are taking to calculate the sample size. Maximum acceptable difference or maximum allowable error is represented in this formula is represented by W. This is the maximum amount of error that you are willing to accept, and confidence level, that is 95%, and its value is around 1.96. Sample size determination formula for single population mean is defined by n equal to z alpha by 2 square into standard deviation square divided by allowable error square. So standard error we can borrow it from past study. W is generally we calculate W or allowable error is generally we consider as a 0.5, and Z alpha by 2 is 1.96. Then it's come as a 1.96 square into standard deviation square divided by 0.05 square, where alpha is the level of significance which can be obtained as 1 minus confidence level, sigma standard deviation of the population, W is the maximum acceptable difference, Z alpha by 2 the value of standard normal table. It is 1.9. Its value is 1.96. If we have a categorical outcome variable or in a proportion, this is the situation in which the variable of interest is categorical. 3 questions must be answered to determine the sample size for single population proportion. Best estimate of population proportion of the variable of interest. Make your best estimate what actual percent of the survey characteristic is. the prevalence or proportion result from that we get from the previous study. If it is not available, then we can go for pilot study to find the this proportion or survey characteristic in which our research, which is our research interest. If the pilot study is not possible, then the judgment by the researcher, which is also not good, then mostly people consider as a 50% if there is no data available. 50%, or we can say it's 0.5 proportion. And this is the formula for sample size calculation. The formula is n equal to z alpha by 2 square into p is the proportion of your interest or prevalence, p into 1 minus p divided by w square. W is the maximum acceptable difference. Z alpha by 2 whole square, its value is around, its value is 1.96. So then it's 1.96 square into p. Suppose there is a no data available, then we consider it as a 0.5, and 1.96 square into 1.5 into 1.96 square into 0.5 into 0.5 divided by, if w we are taking as a 5%, then its value is 0.05 square. Then we put a value, all the value, then we will get the sample size. When our outcome variable is in proportion. For example, one of MPH student want to conduct a research on the prevalence of ANC utilization of a mother in any district. Given that the prevalence from the previous study found to be 45.7%, what will be the sample size? Then suppose he has taken a margin of error as a 5%, confidence level as a 95%, whose value is 1.96. Then put a value of 1.96 square into 0.457 into 1 minus 0.457 divided by 0.05 square, and the sample size calculated as a 382. The final sample size will be corrected. If we are not using a simple random sampling, then we will use then we have to multiply our calculated sample size with the design effect, and design effect we can use as a 1.5 or 2. Mostly research has used 1.5 or 2. Then we will multiply this 382 value with 1.5 or 2. Then our sample size will be changed. Incorrect sample size, if we calculated an incorrect sample size, then it will lead a wrong conclusion. Poor quality research, there is a chance of type 2 error, waste of resources. If we have done a study, then it's a waste of resources, loss of money, ethical problem, delay in completion. So we have to take care during the calculation of sample size. Another example, a graduate student want to do her thesis work on the assessment of outcome of pregnancy among women in the year 2021 in the Pune city. For calculating this sample size, we need a prevalence of any study. We first try to locate, search for a study which is in the Maharashtra. Similar study in Maharashtra, we take if as outcome of pregnancy is means that there is a chance of death of a child. If suppose a child birth is a stillbirth, or if what is the outcome of the pregnancy? If we have a study in a Maharashtra, if there suppose there is 1,000 pregnant women deliver in a particular city or district, and what is the outcome of that variable? We borrow that outcome from that study, and we will calculate the sample size for our research study. Last topic is data processing. If we after collection of data, if how we will process our data. Before data process, we collect the data through a questionnaire. If it is a quantitative data, then we have a quantitative information. We enter all the information in through any software. We can enter through Excel. We can enter in SPSS, and we can also use a data entry software like API Info and CS Pro. So data entry software is very easy to use for data entry. There is a less chance of error, but if we enter using Excel and SPSS, then there is a chance of while entering the data. So I suggest to use API Info software for data entry, which is freely available, or CS Pro software, which is freely available. So whatever you have calculated the data, you first enter that data. Then we can extract that data using we can extract that data in SPSS format as well as in Excel format. So in data processing, in data processing, research is the collection and translation of data set into valuable or useful information. Through this process, a researcher takes a raw data. We extract the data in SPSS. When we have data in SPSS or Excel, it is considered as a raw data, and convert it into a more readable format. We can transport that raw data into a table and graph or chart using a software. Steps in data processing. First step is a data collection. After data collection, we enter the data, that is called storage of data. Then after when your data is entered, we extract that data in SPSS. Then we do a data cleaning. If there is chance of entering wrong data, then we look that data where it is located. If any data entered wrong, by using a frequency run. By using a frequency run, you can able to, if there is a outlier has entered, then you can easily identify it as a during a data cleaning. But if the data is entered wrong, but in a similar type of data which has collected, then it is very difficult to get a wrong data, to identify a wrong data entered in a data cleaning. So for that, generally people, then most of the agency will go for two times for data entry, with two different people enter the same data and then they compare that data. Then that is the process of data cleaning. If you have if a researcher have a money and resources, then they can go for to enter data two times, and then they can compare and clean the data. Then we go for data analysis. Data analysis, we make a statistical analysis, we will make a graph and tables, and data presentation, we present the data through table and graph, and we can make a conclusion of your research topic. Data collection tool, we generally collect the data through four ways. One is face-to-face, is online, through online, and in COVID time we mostly have online survey, and another we can also collect data using email, but email is not email, it's a postal mail. It is not a common in our country, but in Western country, mostly people send a survey questionnaire through a postal way, and people responded to fill that form, and there is also many, if the agency have enough money, they can give some token of money also for that response, and people that fill that survey form and they post back to the agency. And last one is a telephonic way of data collection. Stages in data collection. Data collection is the process of extracting data from available, already discussed. The type of raw data that you collect will have a significant impact on the output you later produce. Researcher must look to accurate, trustworthy, and comprehensive source for valid, usable findings. And the second way is preparation. Through data preparation, we will polish. Preparation means data cleaning. You will polish, organize, filter, and examine raw data for errors. The data preparation stage is meant to eliminate incorrect, redundant, or incomplete data and convert it into a suitable form for further processing and analysis. The goal of the preparation stage is to achieve the highest quality data possible. This is an example of a raw data. Birth weight of 20 infants in a gram born at maternity hospital during a 1 week period in a given below. If we present this data, no one can understand. So we convert this raw data into a meaningful information by tabulation or graph or summary measure. We can calculate a mean birth weight using this data. We can calculate the standard deviation of birth weight of this data, and we can present mean and standard deviation to our audience. Need for presentation. A picture is much more effective than many words or numbers to summarize and comprehend the huge amount of information to form a scientific basis for easy comparison. How we can present the data using a tabular form or using a graphical form. In graphical form, we can use a bar chart, histogram. Bar chart we generally use for when we have ordinal data. Qualitative information, qualitative data. Histogram is generally used for quantitative data. Steam lay plot is for quantitative data. Frequency polygon is for quantitative data. Frequency curve is for quantitative data. Pie diagram is for qualitative data when we have ordinal or nominal data, like that. Now, thank you. This is the end of my presentation. Hello, ma'am.
Yes, sir. Yes. So you have to make me the host. Somehow the connection had some errors. So you are the host of the program.
Yes.
Ma'am, I have one question. If Your Excellency will permit, I wanted to ask one question to Mr. Abrar.
Yes. Yes.
Sir, can you give me one example of snowball sampling, sir? Real life example. Because in example, I understood your slide, but I wanted to get any one realistic example of snowball sampling.
Snowball example, I have gone through one study on snow. It is conducted by one NGO in Mumbai, and it is on FGM, female genital mutilation. It is on female circumcision, which is mostly inherent in the Bohra community. So FGM using a snowball sampling technique. Because the female of that Bohra community has filed a petition in a Supreme Court for banning that practices. But at that time, Supreme Court has told that we do not have data that FGM is practiced in India. We do not have any data for that. After that, by one NGO in Mumbai using a snowball technique.
Okay, sir. Thank you, sir. Got it. Thank you, sir.
Okay, Sergi, doctor, are you hearing me?
Who is?
Abdullah came from Ethiopia.
Okay.
Okay, thank you, doctor, for your nice presentation. Just I am attending it all over the time. I have one question. So in stratified and the cluster sampling method, just the stratas have many different characteristics and they are not homogeneous, they are heterogeneous. So how do we analyze if you wanted to compare the both groups, both clusters? So how do we analyze it in cluster sampling method? And the second question is, what about the difference between research design, research method, approach, and the methodology? They are similar in context, but they I think they are different. So what is the difference about their research design, research method, research approach, and research methodology? Thank you, doctor.
Research methodology is a broad term, and the research method is a subset, is a part of that research methodology. And in research method, or we also got data research method, we have the research design is a subset of research method. Research design is a subset of research method. So in top we have research methodology, then we narrow down to research then we have a narrow down to research design. This is the hierarchy in the research process. And your question on a cluster, how to analyze a study which is used a cluster sampling. Abdul, what was your question?
Doctor, my question is in multi-stage and the cluster sampling technique, they are heterogeneous in their characteristics. So how do we analyze if we wanted to compare both groups? So they are different. For example, if you cluster from high school and from higher education, from universities, from colleges, so the characteristics in these both organizations are different. So how could we analyze to up on a conclusion?
It's totally depend on your research question. If your research question is to analyze among schools, so we cannot compare a school with a college. It's a wrong approach. Our research design is to see some specific characteristic in a school. So in our sample we have only a school, not a college. If we are if we are conducting study in college, then in our cluster will be only a college. We do not select a school. So if we are conducting a study in a hospital, then it is only a hospital, not a nursing home or any medical college. So we have to take care while doing a clustering. Then otherwise it is not possible to analyze.
So, sir, for cluster sampling, so can we take students? So can we compile them, science students and commerce students? Can we combine them, or we need to separate science students separate or commerce students separate? Shall we do that?
No. It's a difficult to compare. If we want to do a cluster of a student of science group, then we make a science group cluster of, suppose you are in Pune, so we have to make a cluster of a science student of each. Can compare.
Okay.
If we want to do a cluster, we can make a cluster of commerce student. We can student. We have to take care of that while making a cluster.
Okay. Okay, sir. Got it, sir. Got it. Thank you, sir.
Any other question?
Yes, I do have one question. I am Sagar from, I'm a PhD scholar studying in JNDU, that is in Punjab. First of all, it was a very knowledgeable session, and
Yes, Sagar.
he said that the sample should be large enough to represent the population. So my query is how to decide that my sample is large enough. For example, if my respondents are 100 in number, then out of 100, how much should be the sample in numbers?
Can you your populations? Hello, Sagar.
Yeah, do I need to repeat the question again?
Yes, your voice was breaking in between. Please repeat it.
Yeah, sure. So I was asking that it is said that sample should be large enough to represent the population.
Right.
But how to decide that my sample size is large enough? If I say that I have respondents of 100, then out of those 100 respondents, how much should be the sample size? How to decide that? Is there any factor? Is there any factor to be considered?
No, no, no. Actually, it's basically a thumb rule. If we have around a 400 sample, na, it
Ji.
is considered as a good sample size.
Ji.
In social sciences, basically, if we have for PhD students, 400 sample size is large enough. But if we are doing a study for any government agency for suppose suppose we have National Family Health Survey. It is in National Survey we have a sample size of around 6 lakh women for India, which is representing the whole India. We have 6 lakh women. This 6 lakh women is distributed in all the union territory as well in all the states. Or then the 6 lakhs divided in different and the sample size is such enough that it will also represent. So if we see the sample size of a National Family Health Survey for a district, it is around 500 or 600.
Okay, so
but
now, yeah, I got
how
my
you
answer.
are selecting this how you are selecting this how you are selecting that 400 is also very important. It's representative or not.
Yeah, the method of selecting the sample.
Non-quality sampling, then it's difficult. It's not representative, but if it's using a simple random sampling, then 400 sample size is enough, large enough.
Yeah, thank you, sir.
Yeah, good afternoon, sir and ma'am.
Yes,
Am I audible? Am I audible? Can you hear me?
yes.
Yes.
Yeah. First of all, thank you, sir, for such a very good presentation and very informative it was. I have a question related to convenient sampling and mainly the pilot sampling. Okay. What is the probability we can take for this sampling? And if we are going to take a convenient sampling, does it affect our result or whatever analysis we will do later on? Does it create anything on whatever the research we have taken? Maybe after presentation or analysis of that result, we will draw the conclusion. So does it going to affect the authenticity of that conclusion if we are going to do the selective study in the convenient sampling or pilot sampling?
If you are using a convenience sampling now, so that convenience sampling through some convenience sampling, whatever the result you got, you will get. It will you cannot tell that the result is representative of the population. But whatever the result you have get, it is authentic. You have rightly collected the data. If you know that I have honestly collected the data, I have done the all the data entry and analysis, whatever the analysis, it is also authentic. But you cannot say it's a representative to the certain population.
Yes, sir. Yes, sir.
You have to.
Got the things. Yes, yes, sir. Thank you, sir. So I forgot to introduce myself. I'm Mrs. Tanuja Jadhav. I'm the PhD scholar from Poona College. And thank you, sir. Thank you very much for your output. Whatever you have told us, definitely will follow it. Thank you, ma'am.
Okay, any other questions? That's all? Okay. I think sir has explained the entire process of understanding the or undertaking the research with in-depth description. So I felt that lesser doubts have arisen, and sir has very in depth, I think he has described the entire sampling technique, how to use, how to determine the sample size, and also various data processing tools. So it was a very, very informative session for all our participants because most of them are researchers and they have enrolled themselves into a PhD program. And thank you very much, sir, for such an enlightening session for our participants. Before concluding today's session, I'm glad to express my vote of thanks on behalf of Department of Economics, AKI Poona College of Arts, Science and Commerce. I express a special thanks to our resource person, Dr. Absar Ahmed, sir, for accepting our invitation, and your expert lecture has truly benefited our participants. I thank our principal, sir, Dr. Aftab Anwar, for always supporting and guiding us. Sincere thanks to our principal, sir, Khan Moinuddin, and special thanks to our head of the department, Dr. Shahid Jamal Ansari, sir, who has put in a lot of effort along with me in organizing this workshop. I'm also thankful to our faculty members, Dr. Vidya Sagar, sir, Dr. Kulnawaz, sir, and Farooq Sheikh, sir, for uninterrupted IT support. I would also thank our participants for joining and patiently listening. Thank you, one and all. With this, we come to an end of our session, and I'm going to share the link for the attendance in a minute. Absar, sir, thank you very much for your time. You have done all.
Any help from my side in future?
Yes.
You can share my email ID with them.
Yes, sir, certainly. And sir,
They contact in future if they want, especially if they want any help from my side.
Sure, sir. Sure, sir. And also, they want your PPT. They all are requesting that we need your PPT. Last time also you have shared, and this workshop also the participants are requesting for your PPT.
Okay, madam, I will share it.
Thank you. Thank you.
Okay, ma'am. Thank you very much. Thank you to all.
Thank you to all.